Now I want to talk about time value of money. Everything we do in finance from here on out is going to be based on these concepts. So it's very important to understand what's going on, and not just the math, but to get the big picture. So to get the big picture, I want to use this example of a money machine, because going forward, I don't care if it's a bond or a stock or if it's some project we're doing or whatever it is. Just think of it as a money machine. I'm trying to find the value of it. So there are three concepts I want to get across real quickly. So let's just say I have for sale this money machine. It's going to pay $10,000 exactly 1 year from today. You have no question. You're 100% convinced and guaranteed this will pay $10,000 1 year from today. How much will you pay for that machine today? So what will you give me for the machine today? Let's just say that I put this thing up for bid and it winds up that people are willing to pay $9,130 for it. Okay, so question number one. What if this money machine didn't pay $10,000, it paid $20,000? Would you pay me more or less? And the answer is, if this thing's going to pay me $20,000 instead of $10,000, you'll pay more, right? I'd rather have more money than less. So the first concept I want you to think about, size matters. So the size of the cash flow is important. In everything we do, we've got to estimate what those cash flows are going to be. All right, question number two. Instead of it paying 1 year from today, what if it pays 2 years from today? Will you give me more or less? Well, I want my money sooner rather than later. I'm not willing to pay $91.30 if it's going to take 2 years instead of 1. I'll pay less. So not only does size matter, timing matters. So the two things we have so far, let me get rid of this, the size and the timing matter. The next thing I want to talk about is the risk. So here are the three things that matter: size, timing, and risk of the cash flows. So what if we say, you know what, instead of this thing paying $10,000 1 year from today, instead of $10,000 1 year from today, I'm going to flip a coin. Heads, it will pay you $20,000. Tails, it will pay you 0. So would you rather have the machine that guarantees you $10,000 or take this risk or this gamble of getting $20,000 or 0? Most people would say I'm willing to pay less money for the risky proposition right here because I don't like risk. But importantly, the three things that matter: the size, timing, and risk of the cash flows matter. Okay, so hang on to that for just a second, and we'll go to the next step here, and I want to talk about specifically how that's going to matter. So in order to do this, I have to draw a timeline. A lot of times people get lazy, they don't want to do it, but you really need to draw the timeline because that's hugely important, because what matters? Size, timing, and risk. So the timeline shows me obviously the timing, and then I put at the bottom the size of the cash flows. And by the way, the interest rate is going to reflect the risk, and we'll talk about that later on. So those three things are in there. The interest rate tells me about the risk. Like I said, I'll talk about that later on. Here's the size and the timing. So if I take $1,000 and put it in the bank, and the bank says I'll pay you 10%, how much will I have in 1 year? Well, a lot of people can say, well, that's $1,100. I can't write it, but I can say it. So a lot of people say it's $1,100. Where does that come from? They give me 10% of the 1,000, which is equal to $100, plus they give me the original $1,000. So when I did this, what did I do? I said, well, the value at year 1, which is equal to 1,000. I'm sorry, I wrote that wrong. The value at year 1, which is equal to 1,100, is equal to the value today, which is equal to 1,000, times 1 plus 10%. I just did that one time, and we'll talk more about this formula as we go through this. So I take this $1,100 and I let it sit in the bank for another year. What happens here? Well, that becomes $1,210. Where did I get that? It's 1,100 times 1.1, which is the same thing as saying $1,000 times 1.1 twice, which is 1.1 squared. If I let this $1,210 sit in the bank another year, it becomes 1,331. Where did I get that? The 1210 times 1.1, which is the same thing as saying $1,000 times 1.1 3 times, which is 1.1 cubed. So the interest rate tells me the step size. I'm going up 10% each step. And then I need to know how many steps I take. So the formula can be written one of two ways. I can say, and this is the way you see it most times, future value equals present value times 1 plus r to the t, which is saying r is the step size, t is the number of steps I take. So in this case, I could say the future value is equal to 1,000 times 1.1 cubed. Another way I could write this, and whichever way you prefer is okay, you can say v for value and give a time subscript. So the value in year 3 is equal to the value in year 0. So in other words, what do I mean by future value? I mean the value in year 3. That gives me a specific time. What do I mean by present value? I mean the value in year 0. Times 1 plus r to the 3, because I'm taking 3 steps, which in general that's going to look like the value in year n is equal to the value today times 1 plus r to the n. So future value, I'm letting money grow, I'm multiplying by 1 plus interest rate for some number of steps. Okay, so let me go back here and talk to you briefly about this interest rate and where it comes from. So what happened in this case, and let me get rid of some of this stuff real quickly. I'm hitting the wrong thing. Get rid of this real quick. So if I'm looking at this, I can say the value in the future. Well, let me write it. Here's the equation. The future value is equal to the present value times 1 plus r to the t. So $10,000 is equal to $9,130 times 1.09529 to the first. Now you can do, I'll show you how to do the algebra in another video for this, but I want to talk about what this means. This 9.529%. This tells me I want to make a trade-off. I'm willing to give up money today to get money in the future, and the interest rate tells me the relationship between the value of money today to the value of money in the future. So this exponent here tells me about the timing. The future value and the present value here, they tell me about the size, right? The risk comes in with the interest rate. The interest rate has 3 things in it. It has what we call the real rate of return, and let me get someplace where it's clear here to write this stuff. It has the real rate of return, and it has inflation. It also has other things like default risk premium. So if this is risky and may not get paid, add a little bit to the interest rate to reflect the risk. I just want you to think of that in a big picture way, not any real numbers to it. The real and inflation is what I want to talk about now. The interest rate I put in here, and the terminology can be confusing, so just try to get this jargon straight. The interest rate I put in right here is what's called the nominal rate. I usually represent that with a capital R. Capital R, 3 equal signs, 3 dashes means I'm defining it this way. It's a nominal rate. And a lot of times people call lowercase r the real rate of return. And we'll use H for inflation. And I can tell you 1 plus capital R is equal to 1 plus a lowercase r times 1 plus inflation. Just a second. So I can solve this and say the nominal rate is equal to the real plus inflation plus real times inflation. So let me tell you about the real rate of return. The real rate of return tells me I'm buying more stuff. So don't think of it as giving up $9,130 today to get $10,000 in the future. I'm giving up whatever $9,130 will buy me. That's the important thing. I'm giving up whatever that will buy me, so in the future I can get $10,000 worth of stuff. Okay, and the inflation rate is saying, look, in a year, 10 grand ain't gonna buy you the same thing 10 grand will buy you today. So in this $870 profit right here, you're making $870 in a year. Well, you're not going to get $870 more stuff. So the real rate of return is how much more stuff you're actually getting, and inflation is the decline in your purchasing power. Alright, so the equation for that, to find, if I tell you you have a 9.529% return, and just let me write it in decimal form. So if I say you have 9,529, part of this is real, part of this is inflation. And the real rate of return is typically around 3%, inflation is usually around 2%. You can get more detail in class about this, but that's what's going on. The nominal rate is the rate that we name, or the rate that we use. Here's the confusing part. You will often see future value equal present value times 1 plus little r to the t. This little r just means interest rate right here. It's not necessarily talking about the real rate of return. So sometimes that's written as 1 plus I to the t. And sometimes it's 1 plus I to the n. Different textbooks, different people, different videos you may watch are going to have slightly different terminology. You just got to work a lot of problems and get used to it. I mean, it's not perfect, but that's the way it is. Alright, so that is video number 1. I'm going to do next video I'll talk about present value and do a few more things.